To understand why moist air is less dense than dry air, we need to focus on the following factors. Number 1, Avogadros principle. And number 2, the molecular weight of water vapor. Let us begin with Avogadros principle. According to Avogadros principle, parcels or pockets of air will always have the same number or amount of molecules if they have the same temperature, pressure, and volume. As long as the temperature, pressure, and volume are the same, they will always have the same amount of molecules even if one of them has heavier molecules than the other. Now let us consider the weight of dry air versus the weight of moist air. Well, dry air is just plain regular air without water vapor. And the air in our atmosphere in its plain simple form without water vapor is composed of 78% nitrogen and 21% oxygen. So for the weight of dry air, all we have to do is focus on these two elements. Nitrogen has a molecular weight of 14, and in our atmosphere it comes in pairs. So in total it has a molecular weight of 28. And oxygen has a molecular weight of 16. And in our atmosphere it too comes in pairs, so in total it has a molecular weight of 32. And now for moist air. Moist air too is just regular air, except it has water vapor, which is H2O. Now H2O is composed of 2 hydrogen atoms and 1 oxygen atom. Each hydrogen atom has a molecular weight of 1, so 2 of them together has a molecular weight of 2. And the oxygen atom, as we learned, has a molecular weight of 16. So in total, water vapor, H2O, has a molecular weight of 18. This means water vapor is extremely light compared to paired nitrogen and paired oxygen, which naturally occur in our atmosphere. So now you can start to see why moist air is less dense than dry air. But to thoroughly understand this, we must go back to Avogadros' principle. And now we are going to consider an example of an empty jar with dry air. If, for example, that jar has 4 paired nitrogen and 1 paired oxygen, the total molecular weight would be 144. And now think about another jar, and this time we are going to put 2 molecules of water vapor inside. But for us to do that, we have to think about Avogadros' principle. The amount of molecules must remain the same. So to keep the amount of molecules inside the jar the same, water vapor will displace some of the other molecules, which are paired nitrogen and paired oxygen. And because water vapor is much lighter than paired nitrogen and oxygen, the overall density of the jar will be much lower. So this is why a parcel of moist air is less dense than a parcel of dry air. And this important fact explains why there can be severe weather and instability between moist and dry air masses. And ironically, moist air or humid air feels more dense than dry air. And some reasons for this is because it's not as easy to breathe comfortably in a moist environment. And it's harder for the sweat on your body to evaporate. But of course, the opposite is true. Moist air is in fact less dense than dry air. So as you can see, it's pretty simple to understand why moist air is less dense than dry air. You can find an online version of this lesson from emeteorology.com. Thanks for watching.